In this question we're told a box has a weight of 10 newtons and sits on a slope that is 40 degrees to the horizontal. What are the components of the weight parallel to the slope and perpendicular to the slope? Use a scale 1 centimetre to 2 newtons. So I'll start by making a little sketch of the situation. We have a slope that is 40 degrees to the horizontal. There is a box on top of that slope, and there is the weight acting straight down, and that is 10 newtons. So to answer this question, we're going to use a scale drawing. And I'm going to start with a horizontal line, and I'm going to put the slope in, which is at 40 degrees to the horizontal. Now I could put my weight vector anywhere I wanted on this slope. I'm not going to worry about drawing in the box, I don't need that for the question. But for convenience, I've already got this little dot here, so I'm going to use that dot. My weight vector needs to go straight downwards, and so it needs to be making, when it reaches this line here, a 90-degree angle. So I'm going to use my protractor to measure 90 degrees. Put the base along my horizontal line. There it's 90 degrees. I'm then going to align my ruler with those two dots there, so the 90 degrees and the dot on the line. And then I'm going to put in my weight vector downwards. Now we're told the weight is 10 newtons and we're to use a scale 1 centimetre to 2 newtons. So my weight vector will need to be 5 centimetres in length. Okay, so that is my weight vector. Oh, it's gone off. There we go. Now, to put in my component of the weight that is parallel to the slope and perpendicular to the slope, I will need to draw a rectangle around that weight vector. Now, to do that, I'm going to start by looking at my parallel component. I'm going to put my protractor onto the line of the slope, so that the 0, that's along the line of the slope. I'm going to move my protractor down my slope until such point where my 90-degree line just touches the end of my weight vector that I've drawn in. Okay, I'll mark that on. I'm then going to use my ruler to draw a line, or line it up to start with that dot that I've created. Can't see it. There it is. The dot that I created there, and the end of my weight vector. Okay. Now this line here, that is now the parallel component of the weight, and I'm going to draw that in a slightly thicker pencil so I can see that. I need to finish off my rectangle. So to draw this side here, I'm going to just go to the end of my weight vector and put the 0 of my protractor, or the cross of my protractor at that point, put the 0 of it along that line that I've just drawn in there. And then I'm going to mark 90 degrees from there. Just lightly draw in a line. And then I need to put in this line across here. And to do that, I'm going to line my protractor up on that line, so the 0 is on the line I've just drawn. And then move the protractor so that my 90 mark is just on the line, meets the line, at the end of the weight vector there. Okay, so I'm just going to put a little mark in there. Going to put my ruler so that it matches up with the end of the weight vector and my 90 mark, and just lightly put that in there. Okay, and now this is the component of the weight that is perpendicular to the slope. So this is my weight, this is my weight parallel, and this is my weight perpendicular. I can now measure the length of those lines. So that is 3.3 centimeters. Now, using my scale, that means that that is 6.6 newtons, and this component here that is 3.7 centimeters. Using my scale, again, that means that it is 7.4 newtons. Okay. So the component of the weight that is parallel to the slope is 6.6 newtons, and the component of the weight that is perpendicular to the slope is 7.4 newtons.